All right. Could I go? Oh, thanks. Hello, everyone. Thanks so much for being here today. I'm Chris Tung, and these are my associates, David Boren and Michael Perez. And over the next 15 minutes or so, we're going to go over our findings relating to an ergonomic evaluation we performed on workplace hazards in a bacon processing plant. So to kick this off, the evaluation was performed in response to a series of shoulder injuries as well as a single thumb ligament injury. This resulted in a total cost of about $140,000 to the company, as well as 63 days of employees spending away from work. Additionally, I'd like to note that there's about 470 employees employed at this plant. So our goal here is to perform an ergonomic evaluation to quantify the potential for musculoskeletal disorders in our workers, as well as to propose abatements to abate these, or to mitigate these risk exposures, and finally to provide a cost abatement analysis. So for our methods, we observed our workers performing their everyday tasks while recording data. This data includes task cycle times, as well as shift and task durations, musculoskeletal loading, such as loads carried in the hands, and finally, static and dynamic joint angles. We use the following ergonomic evaluation tools here to quantify the potential for injuries due to musculoskeletal repetition, manual material handling, and finally, metabolic demand of performing various tasks. Our assumptions here are that our primary endpoint here is to provide priority for change rather than actually getting our company in trouble and giving them a citation. We are also performing this ergonomic evaluation with the intention of catering towards the majority of our working population. So our tasks can be broken into three primary components: applying and removing metal combs meant for hanging pork bellies onto trees for smoking, trimming processed bacon to ensure that it fits into the appropriate packaging, and finally, manual material handling of boxes full of bacon. Also, I'd like to identify what we considered a normal work cycle. A typical workday consists of about 8.5 hours, and 7.5 hours of which are active. So the operator is given about 54 minutes or 12% of the entire workday as rest time. That should actually be 8.5, sorry about that. All operators also rotate tasks about every 2.5 hours. So moving on to our first task, the combing task involves a conveyor belt that drops the pork belly onto the distal end of the working table. The operator actually leans over to grab the pork belly and pulls it towards them, where they then apply the comb by applying a significant amount of force with their hands. So the hazards with this task include frequent extreme trunk flexion, as well as a static trunk flexion of 10 degrees with an asymmetric tilt. The dominant hand applies a significant amount of force to the pork belly as well as the comb in order to insert the comb. And finally, the wrist operates in hyperextension the entire duration of the work cycle. So the abatements we suggest to this are to allow for an adjustable table, preferably between 29.9 inches and 39.2 inches. This is to accommodate varying elbow heights of the different sizes of workers, as well as to incorporate a slant at the distal end of the table, so the pork belly is gravity fed once it comes off the conveyor belt towards the worker, eliminating the need for the extreme trunk flexion to bring it towards them. Additionally, we suggest that workers periodically switch operating hands in order to minimize the amount of force applied by either hand. And then finally, increase the frequency of shift rotations in order to lower the overall types of stress. So here, for our pre and post abatement analysis, in the first column we have our analytical tool that we used. The second column consists of the pre-abatement results of our analysis of each task. And then our third column is the post-abatement analysis with theoretical joint angles and postures taken into account. The red values are values that are considered hazardous or high risk to our employees, and the green values are values that were reduced due to our abatements, as well as are no longer hazardous. As you can see, the Rogers, Rula, Morgark strain index, and work rest cycle identifies this job as relatively risky. After the implementation of our abatements, all of these values significantly lowered, with the exception of the Morgark strain index. The second task was, or the second half of the first task was the decombing of pork bellies. This involves dismounting cooked pork bellies from the smoking trees, placing them in front of the worker, and then manually removing the combs. The hazards involved in this include a static neck flexion of 10 degrees, upper extremity force exertion of 21 pounds. Trunk flexion is, the trunk is statically flexed at 10 degrees, and the non-dominant wrist is operating in hyperextension during the entire task cycle. So our abatements here were to incorporate an automated decombing device, as well as suggestion that the workers periodically switch operating hands, and finally an increase in shift rotation frequency. Looking at our task hazard abatement worksheet again, the Rula and Morgark strain index and work rest cycle once again identified this task as hazardous. After the implementation of our abatements, every single value with the exception of the cumulative Rula score significantly decreased and is no longer hazardous. The second task involved using scissors to trim bacon to ensure that it fits into the appropriate packaging. This task involved a static torso flexion of 25 degrees during the entire work cycle, as well as neck flexion at 10 degrees, significant ulnar deviation in the dominant hand, and high frequency of repetitive cutting motion. The abatements here were to incorporate an adjustable work surface, just as we had for the previous task, and as well as purchase a guillotine-style paper cutter. This would allow the worker to accomplish all of their cutting in one easy motion rather than 10 individual motions. Looking at our task hazard abatement worksheet, the Rogers, Rula, Morgark strain index, or just Rogers and Morgark strain index identified the task as particularly hazardous. After the implementation of our abatements, every single aspect of this task is no longer considered high risk. Finally, our third task involves manual material handling of 15 and 30-pound boxes. The boxes are lifted from a conveyor belt behind the worker and then placed on a pallet 24 inches away. It's important to note that there's very little operating room in between the, in between the conveyor belt and the pallet. The boxes are stacked between 4.5 inches all the way up to 56.5 inches. So the hazards here are high degrees of back and neck flexion, as well as frequent lifting and placing boxes away from the body. And then high torso flexion angles due to the, or trunk rotation angles due to the awkward limited space they have to work in. So our suggested abatements are to raise the conveyor belt or the origin of the lift to 32 inches. So they're no longer stooping to lift the box. Rather, they're just lifting it from waist height. Additionally, we suggest increasing the distance between the pallet and the conveyor belt by 1 foot, giving them a significantly greater amount of room to move within, as well as the purchase of a spring-loaded pallet that also incorporates a rotational function. This allows the worker to, or this keeps the destination of the lift at a constant 32.5 inches off the ground up until the higher stacking tasks. And then finally, increase the shift rotation frequency. Looking at our task hazard abatement analysis, the Rogers, Rula, ACGIH, TLV for lifting tasks, work rest cycle, and NIOSH revised lifting equation for the 30-pound box lifting task all flag this as a particularly risky task. After incorporating our abatements, the only things that are still hazardous are the revised lifting equation for the 30-pound box lifting condition, as well as the threshold limit value for lifting tasks. It's important to note that even though this is still considered risky, it's significantly less so than before. This brings us to our cost of abatements. We've compiled all of our cost of abatements here. We've got a more comprehensive list if you guys need it at the end. But everything costs about $3,500, and this includes labor as well as the parts needed for implementation of our abatements. So for the relatively low cost of $3,460, it's possible to significantly reduce the MSD risk factors that our workers are exposed to, as well as significantly reduce the potential for workers' compensation claims. So looking back at our initial goals, our team was successfully able to identify key musculoskeletal stressors, propose abatements, and provide a cost abatement analysis. We'd like to thank Dr. Bloswick, Dr. Wood, Dr. Pahler, Richard Millett, the company hosting our investigation, as well as all the employees who allowed us to monitor them. These are our references. Thanks so much. Are there any questions?
I really like your costs that you put in there, and as you showed for tasks 1 and 2, one back strain could have, bend it on a back strain or implement your recommendations that you gave them. How happy were they as far as the cost for the material handling? That was a little bit more than that.
Oh, we actually are going to be presenting this to them on Monday, so,
okay.
So this hasn't actually been implemented yet.
So you'll find out.
We'll find out.
One thing I want to add about the cost is we did the most super liberal costs that we could come up with. We believe that in reality, this just involves buying a couple of items. But as we mentioned before, we assume that 7.5 hours is the entire day. We're just saying, assuming a worst case scenario that they need all day to do all changes, and assuming a liberal fee where they pay their labor $100 an hour, we don't think that that cost is going to be any more than $750. And these other items we chose are the most, are either representative or the most expensive, and actually we rounded all each category on there. And so the other thing I'd like to add is that this cost of $4,000 is likely, or $3,500, is likely to be heavily offset by the kinds of savings that would be had, by the kinds of costs that would be had in people having to miss work, workers' compensation claims, and possibly even to have surgeries, or even, goodness forbid, litigations of that sort.
Nice touch, well done.
Thank you. Rock, paper, scissors, to see who goes first. You have your hand raised first.
I'm not sure if you covered, but what's the problems with rotation when they're elected and then put it on the other table with you and how is it rotation?
Oh yeah, there was some trunk rotation due to the fact that there was such limited space between the conveyor belt and the destination. They actually coached their workers not to use trunk rotation when lifting, but sometimes it's unavoidable when they have their boxes stacked up past a certain point, just because of how little space they have.
I wonder if you had any cycle time reduction due to the cutting of the scissors.
Yes.
Oh, yeah.
Yeah, we did have the, so if we could kind of go back to that slide there. That's a good question there. So, yes, so this is the interesting thing about the task. That the original task from a metabolic standpoint, so I just want to be clear that the cycle times are more of a metabolic thing, like how stressful the job is overall for the employee, was actually very low to begin with on the pre-abatement. Not all the tasks were high priority. We actually, our problem with the task ended up simply being that a disproportionate amount of that exertion was placed on the distal hand, which is why the hand was rated as high priority. So it already was so it already actually had a negative value in the rest cycle. A negative rest cycle value means that the employee can withstand more stresses and still be way beneath any kind of risks. But to answer your question on whether the abatement had any effect on the rest cycle, absolutely. It took it from a negative 23, which the firm did a great job by having employees at that kind of stress to begin with, and brought it to a negative 93%. So we are saying that in terms of the overall stress of the body of this thing, that somebody would need to be given, that somebody would need negative 93% of the time. They can withstand a stress substantially more given the abatements we're proposing.
Nice presentation.
Thank you.
What I would encourage you to do, since you're going to meet with the company on Monday, is, I mean, these are great measures for us, but I would look at some of the metrics in terms of production efficiency, because that's what they're going to respond to. And obviously, they're saving some time because they're not, going down to the floor anymore. They're doing it right here. But if you want to get their attention, I would look at those kinds of metrics.
That's actually a really good suggestion.
And then ask them to help you do a return, an ROI, a return on investment, in terms of the cost savings just on the production side.
Okay. Thank
But
you.
a nice presentation.
I think that's a really insightful comment, because one of the big things that we aim to do in ergonomics is we realize that risks can't be brought down to zero, which is why, as you noted, on some of the things there still were some higher priority items. But one thing I'd like to add about the firm is that I felt that this firm places, and my personal opinion is that they place an unusual priority on the safety of the workers. And so I do believe with the firm that we're consulting that their primary endpoint is they just want their workers to be in a better position.
Maybe just one more question. So be careful.
There's two people.
Yeah.
Go ahead. Just having done some work with port buildings before, I know that there's a high coefficient of friction between the port building and tabletop. How are you planning to overcome that with the rain?
So the conditions that they were up to in so the conditions they were operating in is the pork bellies had just come out of the brining.
Injector.
Oh yeah, the brining injector. You're supposed to be anonymous. the pork bellies had just come out of the brining injector, so they're actually really wet, and it's an extremely low friction table, so they'll just slide down easily.
Maybe that was so fast, did you ever try cutting bacon with a paper cutter?
No, but
You might try that first, because my experience with those guillotine cutters is not very good, and bacon's pretty limp.
Well, I think it might work, but I do think we need to think about another potential safety issue with the paper cutter guillotine type device.
Can I just add one thing on there? We did discuss some of those issues, like how difficult it would be cutting the meat. One thing that's really important to note about this is that we're talking about having multiple blades at one time. And the other thing about it is looking at the actual physical condition. What I mean by physical condition being the temperature of the meat while it was being presented to the blades. And so we believe that the stresses that might be put into pulling down the blade with multiple blades would offset the single stress that you'd have to do multiple times. You're talking about cycles of 20 per second or something like that, the old ones.
All right, I think we're gonna have to move on, so let's thank our.
Thank you.